The work carried out by Professor Alf Adams and his team at the University of Surrey back in the 1980s led to a breakthrough in laser technology to produce high-efficiency, high-performance lasers.
Well, actually, I didn't know anything about semiconductor lasers until I went to Japan for a sabbatical leave, and I went there to work at Tokyo Institute of Technology.
So the lasers worked, but they were really pretty marginal in their performance. They didn't work at high temperature, they took a lot of current. And what Alf did was to look fundamentally at the physics of those lasers. Why they didn't work quite as well as we'd expected. Where was the current going that wasn't going into light and such like. So he really revolutionized aspects of the design of the lasers by putting strain into those devices.
This was a purely theoretical idea. The fabrication of semiconductors tends to happen in large, very, very expensive laboratories. And fortunately, someone at Philips Laboratories in Eindhoven understood the idea and immediately went to try to actually fabricate these lasers. And indeed, they managed to do this quite quickly, and immediately the advantage of growing the laser in a state of strain became obvious.
Just because it gives better performance. It tells the electrons where to go, it tells the photons where to go. So it gives a much better efficiency, higher temperature, just overall better performance.
Known as the strained quantum well laser, this technology has found its way into everyday use in systems as diverse as CD and DVD players, metal cutting and welding, as well as enabling light-speed optical communication required by the internet. One of the many new applications is high-efficiency LED lighting.
And if we can actually make lighting much more efficient by using this kind of technology, then it will have a big impact on our impact on the environment and also economic impact as well.
One of the leading companies producing strained quantum well laser devices is Aclaro in Northamptonshire.
Ask someone to count how many lasers they've got in their house. And if it's 2, I'd be surprised. If it's 20, I wouldn't be surprised. They're everywhere. It's been coined that the 21st century will be the century of the photon, as if the 20th century was the century of the electron. Communications, storage, data handling, data communications, medical, defense, sensing, all of these industries use photonics.
So we are at the moment, for example, working with the University of Marburg in Germany to find a way to actually grow quantum well lasers on silicon. And this will enable one to integrate electronics with photonics, and this will be a very important technology of the future.
Sometimes we want we work with the universities because we've got specific problems we want them to solve, and often they've got the brains and the bandwidth and the knowledge to get in there and solve detailed problems. But longer term, it's about ideas and getting the free thinking that comes in the universities.
And research by its nature is risky. Okay, and if it wasn't risky, it wouldn't really be research. Okay, so what universities can do is they can look much further ahead than a company could. They can really look at what might be the technology of the future, 10 years, 50 years even ahead. And that's really what develops the technology and actually the kind of industry that drives the economy forward. Without that, we wouldn't grow as a country.